All right, here is part 2 of this lesson. So the first one was on adding and subtracting radicals. Now we're going to focus on multiplying. So a quick review. When we're multiplying, we're just multiplying those two numbers together. So like 9 times 9 is 81. The square root of 9 times the square root of 9 is the square root of 81. We can multiply those two numbers under the radical and then simplify it, which would give me 9. 6 times 6 is 36. So the square root of 6 times the square root of 6 is the square root of 36, which is really just 6. So you probably are picking up on the pattern that when I do square root of 6 times square root of 6, it just equals 6. So think of those as like two parts that together will make a 6. 10 times 10 is 100. So square root of 10 times square root of 10 is square root of 100, or just 10. Okay, so notice how that when we're multiplying the square root by itself, the answer becomes the radicand, but without the radical sign. So the square root of 7 squared is just square root of 7 times square root of 7, which is square root of 49, which is just 7. Square root of 5 squared is square root of 5 times square root of 5, which is the square root of 25, which just simplifies to be 5. All right, so when we added or subtracted, they had to have the same radicand, meaning the same square root piece. This is not necessarily true for multiplying and dividing. So think of it as we want to put these pieces back together and then pull them apart using our perfect squares if we can. So square root of 12 times square root of 3 is the square root of 36, which simplifies to be 6. Or square root of 2 times square root of 32 is square root of 64, which is really just simplifies to be 8. Square root of 25 times square root of 4 is square root of 100, which is simplifies to be 10. Or square root of 18 times the square root of 8 is the square root of 144, which simplifies to be 12. So we're just multiplying them together under the radical and then simplifying it as we can. Now, not every time are we going to get a perfect square. So when we don't, we just simply need to simplify our answer. So square root of 6 times square root of 2 is square root of 12, which is really the square root of 4 times the square root of 3, or 2 square roots of 3. 12 times 6 is 72. Oh, not 27. But that's really 36 times 2, which is 6 square roots of 2. Okay. Another way to think about it is 12 is really square root of 2 times the square root of 6 times the square root of 6. And then think about what we talked about up front, or up top. Square root of 6 times square root of 6 is just 6 square roots of 2. So square root of 15 times square root of 3 is square root of 45. Well, that's really square root of 9 times square root of 5, which is 3 square roots of 5. Or another thing to think about is this was really square root of 5 times square root of 3 times the square root of 3. Square root of 3 times square root of 3 is 3. Oh, and I miswrote this part down here. That was supposed to be square root of 5 down there. So here, square root of 2 times square root of 22 is square root of 44, which is really 4 times 11, or 2 square roots of 11. All right, so occasionally we're also going to have to deal with the coefficients. So we're just going to do it in waves. First, we're going to multiply the coefficients on the outside. So 2 times 3 is 6. Then we're going to multiply the radicals on the inside. Square root of 5 times square root of 8 is square root of 40. Then we simplify. Square root of 40 is really square root of 4 times square root of 10. Well, square root of 4 is really just 2 times 6 is 12 square roots of 10. All right, so let's see this all in action. So I'm going to multiply my whole numbers. 5 times 4 is 20. Then 6 times 8 is 48. But now, simplify if we can. 48 is really square root of 16 times square root of 3. Square root of 16 is just 4 times 20 is 80 square roots of 3. Here, negative 4 times 7 is negative 28. Square root of 3 times square root of 15 is square root of 45. So I get negative 28. 45 is square root of 9 and square root of 5. Well, that's really just 3. So I do 28 times 3, and I get negative 84 square roots of 5. Here, 2 times 4 is 8. 5 times 10 is 50. But that's really 25 and 2. 25 is really just, square root of 25 is really just 5. So 8 times 5 is 40 square roots of 2. All right. Last couple here. So 3 times 9 is 27. 2 times 20 is 40. Well, that's really square root of 4 times square root of 10, which gives me 54 square roots of 10. Here I have negative 1 times 6 is negative 6. 12 times 5 is 60. Then I look for my perfect squares. In this case, the only perfect square is a 4. So square root of 4 times square root of 15. Well, that's really a 2, so negative 12 square roots of 15. Here, this is really square root of 16 times the square root of 16, which is just 16. All right. Here, I'm going to have to do a little bit of careful work. So I got to do in my parentheses first. So before I can do anything, I need to have my square roots both equal to each other, or have a common square root or common radicand. So square root of 12 is 4 times 3, and 8 is 4 times 2. So this becomes 6 square roots of 3 and 10 square roots of 2. I didn't end up with any that are in common. I don't have the same radicand, so I can't combine those together. But I can distribute that piece on the outside. So 2 times 2 square roots of 7 times 6 square roots of 3 is 12 square roots of 21. And then I multiply times the next one. 2 times 10 is 20. 7 times 2 is square root of 14. Now, they don't have any common factors in that radicand there, so I can't combine it together any farther than that. Okay. So this one, I'm going to have to FOIL, or my double distributive. So 4 square roots of 3 times 3 square roots of 10 is 12 square roots of 30. And then 4 square roots of 3 times 5 square roots of 6 is 20 square roots of 18. And I'll come back and simplify anything I can here in a little bit. Then negative 2 square roots of 5 times 3 square roots of 10 is going to be negative 6 square roots of 50. And then negative 2 square roots of 10 times 5 square roots of 6 is going to be negative 10 square roots of 30. All right, now I try to see what can I combine and what can I simplify. So I have 12 square roots of 30 minus 10 square roots of 30 is 2 square roots of 30. 18 can be broken into a 9 and a 2. Well, that's really a 3. So 3 times 20 is 60 square roots of 2. 50 is really square root of 25 times the square root of 2, which is really just 5. So negative 30 square roots of 2. So I just simply simplified those two terms. Those are like terms that I can combine together. 60 minus 30 is minus 30 square roots of 2, and my 2 square roots of 30 out front. So lots of pieces there, but that's what I would get if I were to combine those terms together.